Alright everyone, here is one of your most asked for videos. Everything you could want to know about the TRAPPIST system. And I can see why there is so much interest. It is such a unique system compared to anything else that we know of. An entire solar system contained well within the distance of Mercury and the Sun. It is one of the closest places to us that could harbour alien life outside the solar system, it being only 40 light years away from us. That means we won't be visiting it anytime soon. But with improved technology from the James Webb Space Telescope, we will be able to gain an insight into another solar system like never before. I'm Alex McColgan and you're watching Astrum, and together we will go through the TRAPPIST system and see why it is so special. Let's begin at the heart of the TRAPPIST system, TRAPPIST-1 itself. The ultra cool red dwarf star. A star which is just a little bit bigger than Jupiter, but a lot more massive. Red dwarf stars are the most common type of star in the galaxy. Even our closest neighbour, Proxima Centauri, is a red dwarf, as is 50 of the closest 60 stars to us. Being so cool means they are very long-lived. Stellar models suggest they could exist for trillions of years, which is far more than the current age of the universe. Although there are many known red dwarfs with exoplanets around them, typically red dwarfs are dubious candidates to have life. This is because the Goldilocks zone, or the distance from the star where water could theoretically pool on the planet's surface, is extremely close to the parent star. Meaning any exoplanets orbiting in this zone are likely tidally locked. This means one side to the planet would always be facing the star, and the other side would be in perpetual night. The night side would be cold enough for gases in the atmosphere to freeze. Also, red dwarf stars are often flare stars, or stars that can have their brightness increase very rapidly to magnitudes brighter than they are normally. This is similar in a way to a solar flare on our Sun, but on a much grander scale. This variation in temperatures and radiation is not good for life to develop on any planets nearby, or for planets retaining their atmospheres during a huge flare. TRAPPIST-1, however, while being a red dwarf, does not flare up as much as its other red dwarf cousins, 30 times less than a typical red dwarf star, great for the chances that atmospheres exist on the exoplanets around the star. All the exoplanets are likely to be tidally locked to the parent star though, something we'll come on to later. Which leads us nicely to the planets of TRAPPIST-1. TRAPPIST-1 has astounded scientists in that it has 7 known Earth-sized planets orbiting it. Optimistically speaking, 6 out of the 7 planets orbit within the system's Goldilocks zone. These planets are so close together. The furthest out planet still only orbits at roughly 9 million kilometers from the star. In comparison, Mercury orbits our star at 58 million kilometers. Let's go through what we know about each of TRAPPIST's exoplanets. It should be noted though, that our current observations aren't going to be perfect and will only improve as time goes on, but this is what we think at this point in time. TRAPPIST-1b, the closest planet to the star. It is slightly larger than Earth, but with the same mass, meaning surface gravity would be about 80% of Earth's, quite similar to Venus. It is also similar to Venus in that it has extremely thick atmosphere, potentially full of CO2, meaning that because this planet only orbits 1.7 million kilometers from the star, it's gonna be really hot. A year on TRAPPIST-1b lasts only 36 hours. This atmosphere could also be rich in water, and surface pressure is likely to be 10,000 times greater than Earth's. With such close proximity to the star and significant greenhouse gases, surface temperature is thought to be between 500 and 1700 Celsius. Not the ideal place for our type of life then. TRAPPIST-1c is the next planet, orbiting at 2.4 million kilometers away from the star. Its year lasts 58 hours. At this distance out, it is getting about 2 times the starlight Earth gets from our Sun. Its size and mass are about 10% more than the Earth, which means it has a very similar gravity to Earth. It is very similar to TRAPPIST-1b in that scientists believe it to also have a thick water vapor atmosphere, although TRAPPIST-1c's is probably less thick. This means its surface temperature is likely to be hot, but not as high as TRAPPIST-1b. Next is TRAPPIST-1d. Only an extra 1 million kilometers further out than TRAPPIST-1c. 1 year lasts only 97 hours. TRAPPIST-1d is kind of like a mix between Earth and Mars, as it's 30% smaller than Earth and only 30% as massive, meaning the surface gravity is little under half of Earth's. It is found on the inner part of the Goldilocks zone, meaning at this point in the solar system, the surface temperature is now cool enough for water to pool on the surface. It only receives 4.3% more starlight than Earth, and combine this with solar flares from the star, it is likely to still be pretty toasty for our standards. TRAPPIST-1d has been found to have a volatile layer on the surface, perhaps an ocean or a thick atmosphere. And this is where oceans and atmospheres become very important. Because as I mentioned, all these planets are likely tidally locked, meaning a thin atmosphere or no atmosphere means that one side of the planet would be scorched and the other side would be freezing, much like what happens with Mercury. Venus, on the other hand, has a thick atmosphere which circulates the heat around the planet, meaning night or day, the temperature is the same. So if these TRAPPIST exoplanets, like TRAPPIST-1d, has only a thin atmosphere or small ocean, the chances are that one side of the planet would be devoid of anything but rock, the other side might be covered in ices. There might be a small band of habitability along the twilight zone, but that would be it. With a large ocean or atmosphere, the planet might be able to distribute the heat much better, meaning it would be habitable all over, as much as we understand habitability anyway. This planet may well be an ocean world, with over 250 times the amount of water more than Earth's oceans. Although other studies have suggested the atmosphere could also be similar to Venus's, we will get a better understanding from the James Webb Telescope. TRAPPIST-1e orbits another 1 million kilometers out again, at 4.4 million kilometers from the star. Its year takes 146 hours, and at this distance it only gets 60% of the starlight Earth does. Size, mass and gravity are all very Earth-like, and it is probably the only planet in the TRAPPIST system to have a rock-iron composition like Earth. It also has a compact, hydrogen-poor atmosphere, which is good as hydrogen is a strong greenhouse gas, and would make the planet inhospitable from this distance. With this compact atmosphere, water could pool on the surface, and the temperature would be very Earth-like, if a little cooler depending on the albedo of the planet and how much heat the atmosphere retains. All in all, it is considered one of, if not the, most Earth-like exoplanet that we know of, and it's going to be one of the first targets of the James Webb Telescope to try and detect signs of life. How amazing would it be if it really was a cousin to Earth only 40 light years away? From TRAPPIST-1f and beyond, we're still in the Goldilocks zone, but it's starting to get much cooler at this distance. TRAPPIST-1f orbits a distance of 5.8 million kilometers from the star, and a year takes 220 hours, or roughly 9 days. Its size is very Earth-like, although it is less dense, meaning surface gravity would be about 80% of Earth's. The most recent studies on this planet have suggested that its low density means it is likely to be 20% water, which at this distance from the star would cause a massive greenhouse effect, meaning the water would be in gaseous form. This is known as a steam world, and it would probably be no more habitable than the ice or gas giants in our solar system due to the high pressure and temperature on the surface, likely in the hundreds of degrees Celsius. TRAPPIST-1g is slightly bigger than Earth and orbits at 7 million kilometers, taking 12 days to do so. There hasn't been too much information discovered about this planet, other than water has again been found on it. This planet is still found in the Goldilocks zone, although right on the far edge, so it is still a candidate for habitability. And lastly, TRAPPIST-1H. It orbits at 9.3 million kilometers and takes 19 days to do so. It's the smallest of the known exoplanets in this system, and also the least dense, meaning its gravity is comparable to our moons. Due to the cool nature of the host star, being this far out means the planet is likely icy, as it does have water. Theoretically, it could also have liquid water on the surface if it had a hydrogen-rich atmosphere to act as a greenhouse gas, but again, little is known about this planet. So that's all the planets. Could this system really be habitable? Well, it depends on a number of factors, but what we've seen so far is promising. Water has been detected on most, if not all, the planets. The host star is a red dwarf, but not a very active one. If these exoplanets have strong enough magnetic fields, they could deflect a lot of the solar wind. If any of them do have magnetic fields, I can't imagine how glorious some of the aurora on those planets would look like. They are also all roughly Earth-sized, with similar gravities and densities. Not a huge factor for life, but we know it worked here. And lastly, although these planets are tidally locked, they may still have mechanisms for evenly distributing the heat across the planet. All in all, TRAPPIST-1 is such an interesting system, and I can't wait to see what we find out about it in the future. My fingers are crossed, my thumbs are pressed. I'm praying that James Webb Telescope launches successfully in 2021. What it is going to see in the universe will be astounding, I guarantee it. Thanks for watching. Well, it's the holidays, and if you're like me, you don't especially enjoy materialism. Well, okay, I do sometimes. But gifts don't always have to be materialistic. Do you know someone who likes to ask, how does gravity work? Or how do they know the size of the universe? Or maybe even, if we can't directly see exoplanets, how do we know they exist? If so, I have the thing for you. You can now gift a subscription of Brilliant.org to family or friends. I love this because it's a fun way to nurture curiosity, build confidence, and develop problem-solving skills crucial to school, job interviews, or their career. Go to brilliant.org/Astrum and grab a gift subscription to help your loved ones finish their day a little smarter. Want to know more about our universe? Subscribe for more videos and to check out what I've covered in the past. Liking and sharing helps a lot too, and if you really want to support the channel, I also have Patreon. Donate to have your name added to this list. All the best and see you next time.